Okay, a few more for you to do. Follow along and just graph as you will. If you subtract inside the function, that moves it this many units to the right, right? This is going to go pi over 2 to the right. I want you guys to know that when you move left or right, it's got a name. And the name is, it's a phase shift. It's a phase shift. I don't know if we said that in December or not. Okay, the sine function normally starts at 0, ends at 0, there's a 0 in the middle. So what I'm going to do is once again, I'm going to do a real light dotted version of the sine function, then I'm going to move it, okay? So there's this point, this point, this point, there's one down here, and there's one up here. Hopefully you guys are getting real good at this. Okay, now I'm going to move every point pi over 2 units to the right. How far is pi over 2? Well, according to this thing, it's 1 notch. That's the distance pi over 2 on the x-axis. So move every single point 1 notch over to the right. This 0 goes over 1. This maximum goes over 1. This 0 goes over 1. So the first part of my graph is going to look like that. See what's going on? I just moved it to the right. This, I moved that 0, so this -1 goes over to here. This 0 moves over. This maximum moves over. Maybe it might be a good idea to go 3 at a time, just so you get the feel for it. This 0 moves over. This -1 moves over. And so it looks like this. If I go backwards, obviously, I'm going to hit a -1 down here, so I might as well just fill in the rest of my graph, right? Am I right? Okay. This thing just moved to the right pi over 2 units. That's a phase shift. And it's if it's going to the right, we would actually call it a phase shift of pi over 2, meaning it goes to the right even though you have a negative in there. You would call the phase shift pi over 2. Cosecant of x, and we're going to go plus 2. Now cosecant of x, one more time, it's 1 over sine. So look, I'm not going left or right here. I'm going up 2 units. So I got to find out where sine is 0 and make asymptotes. Well, where is sine 0? I can either look it on here and go, there's sine of 0. It's the 0 and pi and 2 pi and negative pi. It's all the pi's. Or I could go to get my cosecant graph and I go, hey, look, it's at 0 and pi and 2 pi and negative pi. It's all the pi's. So let's put some asymptotes at all of these 0 and pi angles. -2 pi, pi, 0. Now the reason that I don't have to move these is because I'm not moving left or right. If I had to move left or right, I would have to move every one of these asymptotes, right? Now since it's 1 over sine, it would start here, it would go up, it would go down, it would go down to -1 and start. So there is the sine function. Now we're supposed to make parabolas, right? So I put a 1 there and put a -1 there, and we'll make my parabolas. What I'm supposed to do is put a point here and here and here and here, and then draw parabolas. But everything goes up plus 2. So this point's not going to be at 0. Sorry. It's not going to be at 1. It's going to go up 2, and it's going to be up at 3. This point's not going to be at -1. It's going to go up 2 and be at +1. This point's not going to be at 1. It's going to be up at 3. This point's not going to be at -1. It's going to be a +1. So they're going to follow the way they were going to go. They just moved. So way up here, I've got parabolas going up, and then here I've got parabolas that are opening down. You guys see what this looks like? So you guys are good at figuring out if I'm supposed to go left, right, up, down, all that kind of stuff. I think you should be good at this also. You just got to remember how to start the parent function, and then where does it go? Cotangent of x plus pi over 2. So this is going to be interesting. Now, this means that I've got to go, it's a phase shift. So I'm going to write phase shift again, because I want you to get used to that phrase. And this one's going to go left pi over 2. It's a terrible looking pi right there. Left pi over 2. Now, let me just go back and sheet here. And I'm going to look at the cotangent graph. Now, where are all of these asymptotes? For cotangent, it's 1 over sine, just like the last one. And so the asymptotes are at all the pi's, right? The asymptotes are supposed to be at all the pi's. But I'm moving left pi over 2. So instead of here, I'm there. You see what I mean? So here's what I'm about to do. Where were they supposed to be for cotangent? They're supposed to be at 0 and pi and 2 pi. So I'll make like a little dash almost. That's where the asymptotes would be. But since I'm moving to the left pi over 2, I got to take every one of them and move it to the left, pi over 2. That's one notch again. So this one goes over here. I had to actually make up a spot. This one moves over to this negative 3 pi over 2. That was this. The 0 moves over to negative pi over 2 here. I didn't go high enough. That's funny. Those go on forever. Okay. Pi goes over to pi over 2. So now it's starting to look like a tangent graph. 2 pi goes to 3 pi over 2. This is the tangent. It has the asymptotes at the pi over 2's. But the difference is it's not a tangent, it's a cotangent graph. So what do? I don't make increasing swooshes. I make decreasing swooshes. Here's the graph of the cotangent of the quantity x plus pi over 2. Move the asymptotes as best you can. Put the zeros where they go, and then draw a cotangent, which is a decreasing swooshy. Now, obviously, looking at this example, if I put a plus 4 after this, we're going to move these points up to 4 and then just do decreasing swooshes. If I put a negative in front of it, I'm going to flip it, and it would be exactly the tangent graph. How about that? Okay, if I have secant of x over 2, this number affects the period. Okay, we learned this right before winter break. The period is always going to be 2 pi divided by b, and that's from y equals the sine of bx. Okay, if x is being divided by 2, it's not multiplied, so it's like it's multiplied by a 1/2 right there. And secant, and I should be talking about cosine instead of sine because this is 1 over cosine, by the way, sorry. But since this is like the secant of 1/2 x, what I'm really doing is I'm dividing 2 pi by 1/2. And if you take that and flip and multiply, 2 pi times 2 over 1 is 4 pi. So the period is 4 pi. Now secant, let me go borrow my secant graph. Now look what's going on with secant. Normally I go from negative 2 pi over 2 to pi over 2. It splits over the origin, right? Splits over the origin. If you go from negative pi over 2 to pi over 2, that's 180 degrees, you guys. That's pi. Right? Nope. Yeah. From negative pi over 2 to pi over 2, that's 180 degrees. That's pi. So I have asymptotes pi units apart. Now, this period is 2 pi if you go the top parabola and the bottom parabola. I mean, that's what I'm looking for. This is the period. That has to end up being 4 pi. But what I'm going to do is I'm just going to get the distance right here. I'm going to double that distance. If I'm going from 2 pi to 4 pi, I'm doubling the distance. So I'm going to start at 0. I'm going to go out twice this distance and hit down at pi. I'm going to go down to negative pi. I'm going to make that distance twice as wide. So look, I go, instead of at pi over 2, I'm going to go to pi. Instead of negative pi over 2, I'm going to go to negative pi. Now that distance from negative pi all the way to pi, from negative pi all the way to pi, now that distance is 2 pi. That's going to be half of the period for this thing. Period's 4 pi. So how does the secant function actually look? There's a parabola going up in the middle. It starts at 1, so I'm going to start it at 1. And it goes up in the middle, but this is going to be much wider, right? Okay. And what's my distance? 2 pi units. So if I'm at pi and I add 2 pi, I'm all the way out at 3 pi. So there's 1. I'm sorry, pi over 2, there's 2 pi. There's going to be a 5 pi over 2, and then 3 pi would be way out here. So I'm going to put another vertical asymptote way out at 3 pi. I'm going to do the same thing over here. There's pi over 2 and then 2 pi. There would be another pi over 2 that's negative 5 pi over 2. And then negative 3 pi would be way out here. Okay, and you can see these are all the same distance. They're all 2 pi. Now, since this one was up, this is going to be down at negative 1. And when I graph this parabola going down, I know that I'm going kind of fast, but look. This goes from negative pi all the way to 3 pi. That's the period. That's the 4 pi period right there. It goes up and it goes down before it starts repeating. So I'm going to draw in here period equals 4 pi, just so you guys see it. Okay, then over here, this would go down 1 and I'd have another parabola down here. And I'm starting to repeat myself, right? I already have this one. So this is really the part of the graph that matters to me, is that you guys get that the period is 4 pi. And if you got one going up, one going down, it should make sense to you that in between the asymptotes is 2 pi here and 2 pi here to make up that 4 pi. That's how we graphed it. Okay, 2 more, and then I'm going to call it a day, and I'm not going to assign any homework again today. I'll give you guys some homework to do tomorrow. All right, negative sine of x plus 2. Well, negative sine of x. Sine starts here, sine finishes here, sine goes there. It normally goes up and then down, but if it's negative, it'll go down first and then up. So there's negative sine of x. So let me go here. There's a 0 at negative 2 pi, a 0 here to end. It normally goes up first, but this one will go down. This will go up because that negative has flipped my graph. There's negative sine of x. And then if I'm going to add 2, just add 2 to everything, right? These two maximums go all the way up to 3. 1, 2. These zeros are at 0. They're going to go up to 2. That's up to 2. That's up to 2. That's up to 2. That's up to 2. And that's up to 2. And the negatives go from negative 1. If I add 2 to those, I get 1. So, ladies and gentlemen, there is the graph of negative sine of x plus 2. It just moved up 2. All right, and then the last one for me for today is the tangent of x over 2. Again, if I'm multiplying or dividing to the x, I'm affecting the period. This is a period problem. And when I have asymptotes like this, if I'm making the period wider, I got to make the asymptotes further apart and then draw my graph. So now this period is usually pi for tangent, so it's going to be pi divided by 1/2 this time. It turns into 2 pi. Okay, I've got to have a period for tangent of 2 pi. Now the tangent graph, like the cotangent graph, is just one swooshy. And I'm saying the distance between asymptotes now is going to be 2 pi because once I get through one swooshy, I start repeating myself. Tangent and cotangent have a smaller period than secant and cosecant, right? Now how does the tangent normally go? Since tangent is sine over cosine, let me just write this right here so you guys see it. I'm looking for asymptotes originally where cosine is equal to 0. Where is cosine equal to 0? Up at the top at pi over 2, down at the bottom at 3 pi over 2. I normally have my first two asymptotes right here. Okay? That distance is pi. But we've decided I need that distance to be twice as big as it normally is, so it's got to be 2 pi. So I'm going to go twice as far and twice as far, and I'm going to put asymptotes at negative pi and positive pi. So that way, this distance right here is 2 pi. That's the whole period, that's the whole swooshy. So I just draw a swooshy that goes through the origin and is wider than normal. Now if this distance is 2 pi and I'm sitting here at pi to get my next asymptote, add 2 pi to that and you got 2 pi, 3 pi. The next asymptote would be all the way out here at 3 pi, and you just put another swooshy that goes through 2 pi and goes up. You want one over here? There's negative pi. I'm going to go to negative 2 pi and then negative 3 pi like I did before. Because this is a tangent function with a smaller period, I just keep repeating myself. And I get 3 periods of the tangent function. Hey, that was a lot. I hope you guys, if I went too fast, just kind of go through it and pause so you make sure you're thinking through and stuff like that. Tomorrow, I'll probably, I think what I'd like to do, let me flip this over real quick, is, oh, look at that, there's more. Guys, we could have done 12 more. I'm so disappointed. I'm going to write some stuff. You don't have to write this down right now, but we're going to do this. A times like the sine of bx minus c plus d. We're going to talk about what all 4 of these numbers do to the graph, and maybe even like if there's a negative. And then maybe I'll give you some equations, and I'll have you just describe what's supposed to happen without graphing it. We did enough graphing for the last 2 days. And so I think that's what your notes, I'll do some, looks like notes tomorrow where we actually describe the behaviors here and you say what's supposed to happen. And maybe just, I think was probably a good idea, a little bit of practice with, where's it at, where you have to change where the asymptotes go. That's probably not the worst thing to practice. So that's what we'll do tomorrow, Wednesday for your Zoom meeting. And I will see you guys then. Have a good day.